All right. So we are supposed to decide what type of triangle these are. So 3 possible types of triangles here. We have acute triangles. If it's acute, then c squared will be less than a squared plus b squared. If it is an obtuse triangle, then c squared will be greater than a squared plus b squared. And if it's a right triangle, then c squared will be equal to a squared plus b squared. Yes?
No, not. So is this formula going to be on the test, or do you have to write it down?
You have to know this. This is Pythagorean theorem. You do have to know this one. It won't come on the test. So Pythagorean theorem is normally a squared plus b squared equals c squared. We're using the converse of it. That's why it's backwards. So when we're looking at these 3 problems, the way I know which ones are A, B, and C, A and B are interchangeable, but C has to be the biggest one. So 5 would have to be C, 15 would have to be C, square root of 17 would have to be C. The biggest one has to be C. So now we're going to substitute in and see what happens. So I would take 5 and square it. I don't know yet whether that's equal to, less than, or greater than. And then we have to take 3 and square it and add that to 4 squared. What is 5 squared? 25. What about 3 squared? 9. 4 squared? 16. We have to add the 9 and the 16 together. What is 9 plus 16? 25. So the 2 sides of my equation are equal, so it's a right triangle.
You got a right triangle? You got a right, W-R-I-G-E. What you think? Triangle.
Yep, you have to write right triangle, R-I-G-H-T. All right, then we do the exact same thing on part B. We take C, which is 15, and we square it. I don't know yet whether that's greater than, less than, or equal to, so I'm going to put a question mark there. And then we take the 4 and the 12, we square them both, and we add them together. What is 15 squared? 225. You guys already told me that 4 squared was 16. What is 12 squared? 144. We have to add the 16 and the 144 together. 160. Did they come out to be equal? Which one's bigger? 225. C squared is bigger, so that means it's obtuse. I do too. It's a fun word to say. All right, then for part C, all of these have square roots over them. We have to take them all and square them because that's what Pythagorean theorem says to do. So square root of 17 squared. Then a big old question mark there. And then we have the square root of 5 squared plus the square root of 13 squared. Yep, those cancel on all 3 of them. So I end up with 17 on the left, and on the right, I have 5 plus 13. And 5 plus 13 gives me 18. 17 is smaller than that. So since c squared is smaller than a squared plus b squared, it's an acute triangle. Number 2, absolutely we can do number 2.
Isn't it the same?
No, number 2 is not the same. This one is asking for what type of triangle it is. Number 2, I want to know which ones of these are Pythagorean triples. So I'm not asking for what kind of triangle it makes. I want to redefine a Pythagorean triple for you guys. This is 3 whole numbers that satisfy a squared plus b squared equals c squared. What'd you say? There's none in the first one. 8, 10, and 16. Well, we got to use all of them. We got A, B is C. So again, the biggest number has to be C. So we're going to see if this one works out. It has to be A squared plus B squared equals C squared, or it's not a Pythagorean triple. So I would have 8 squared plus 10 squared equals 16 squared. Well, I know 8 squared is 64. I know 10 squared is 100. What is 16 squared? 256. 64 plus 100 is 164, right?
Yeah.
Are the two sides equal? Then it's not a Pythagorean triple. Cross it out. C always has to be the biggest, yes. So on the next one on part B, 8 would have to be my C value. So then we're going to do it again. 6 squared plus 7 squared needs to come out to be equal to 8 squared if this is a Pythagorean triple. So 36 plus 49 equals 64. What's 36 plus 49? 85. Did that come out to be 64? So is it a Pythagorean triple? No. All right, the next one. 13 has to be my C value now. So 5 squared plus 12 squared equals 13 squared. You guys already told me that 5 squared is 25 and that 12 squared is 144. What's 13 squared? 169. What is 25 plus 144? 169 equals 169. This one came out to be the same on both sides. So this one is a Pythagorean triple. All right.
Oh, we don't do the last one?
Well, we're doing the last one now. Very last one here. Square root of 6 squared plus the square root of 8 squared equals the square root of 14 squared. Squared and square roots all around cancel each other out. So then I would have 6 plus 8 equals 14. What is 6 plus 8? 14 equals 14. This is looking promising, except this is not a Pythagorean triple. Good question, yes. What'd you say? They're not whole numbers. To be Pythagorean triples, we have to have 3 whole numbers. Square root of 6 on the calculator is not a whole number. Square root of 8 is not a whole number. Square root of 14 is not a whole number. These are not whole numbers. If they're not whole numbers, can't be a Pythagorean triple. What else would you guys like to see? Yes. Question 6, the first one. Same size as last review, though. Same number of pages. Yep, 3 pieces of paper. All right, we're supposed to use our special right triangle rules. Thank you, dear. As soon as Sydney gets back. Let's write down our special right triangle rules before we go forward with this at all. For a 45, 45, 90 triangle, we have one rule. The hypotenuse is equal to the leg times the square root of 2. This is another one of the things that you have to know and memorize for the test. On a 45, 45, 90 triangle, the hypotenuse is equal to the leg times the square root of 2. On a 30, 60, 90 triangle, we have two rules that we have to remember. The hypotenuse is equal to the short leg times 2, and the long leg is equal to the short leg times the square root of 3. So in addition to SOHCAHTOA, a squared plus b squared equals c squared, you have to know these three rules as well. On homeworks? Yes. 8, 1, and 9, 1. 8, 1, and 9, 1, yes. Number 6 on the first one. What are we looking at here? What type of a triangle is that? A right triangle. What kind of special right triangle is it? 30, 60, 90 triangle there. Sticking together. So we're going to use our 30, 60, 90 triangle rules. What part of the triangle have we been given? The hypotenuse. So the first thing we need to do is find the short leg. Yes, 6 square root of 3. Thank you. All right, so hypotenuse is equal to the short leg times 2. This is opposite that right angle. So this is my hypotenuse. So 12 square root of 3 is equal to, they're calling the short leg n. So n times 2. We divide both sides by 2 so that we can get n by itself. And because these are both whole numbers, we have to divide those. 12 divided by 2 gives me 6. So that's why we get 6 square root of 3 for the short leg n. The long leg is equal to the short leg times the square root of 3. The long leg they're calling m. We just found out that the short leg is 6 square root of 3 times another square root of 3 to get my long leg. Yes. 6 square root of 3, or 6 times square root of 3 times square root of 3. Notice I got two things that are the same times by itself. That is something squared. So this is 6 times the square root of 3 squared. Squared and square root are canceling each other out. So I have 6 times 3. And 6 times 3 is 18. So the long leg is 18. Do you guys want to see any of the others in number 6 or a different problem, or what do we want to work on next? Good. Number 20. Number 20. Number 20 has 4 parts to it, and it says to solve the right triangle. What are we looking for if it says to solve the triangle? and the missing angles. You have to find all the missing sides and angles. Right. On part A, we can get our angle real quick, yeah. Measurement of angle K plus 90 plus 35 is equal to 180. What is 90 plus 35? 125. So the measurement of angle K plus 125 is equal to 180. And then you subtract 125 from both sides. You get 65. That's exactly what I just did. I just wrote it slightly differently. We added the 90 and 35. That's where the 125 came from. And then I minused it from 180. You got 55? Okay. I thought you said 65 at first. I'm not looking at my answer key right now. Let me double check that by looking at my answer key, though. It is 55 degrees. All right. It helps if I look at my answer key. Then we have two missing sides that we need to find. We need to find LJ, and we need to find KJ. Which one do you guys want to find first? KJ sounds good. That is our hypotenuse. We're going to stand at the angle that they gave us. So we're going to stand at this 35-degree angle. So the opposite side would be this 15 over here. And LJ is my adjacent side. You guys said that you wanted to find KJ first. You wanted to find the hypotenuse first. And we know the opposite side. So SOHCAHTOA. We're looking for the hypotenuse. That means I'm not going to be able to use tangent because it doesn't have the hypotenuse. And we know the opposite side. So we're going to have to use sine. So sine of my angle, sine of 35 degrees. Is equal to opposite, which is 15, over the hypotenuse, which is x. Or I'm going to put in KJ here. But if you want to use x, there's nothing wrong with using x. SOHCAHTOA? Nope. You have to know SOHCAHTOA. Good questions, though, guys. Very good questions. My unknown thing is KJ. Again, you can use x in the place of KJ. That's fine. But we would have side KJ times the sine of 35 degrees is equal to 15. And then we would have to divide both sides by the sine of 35 degrees. What'd you say? Double check that. I got something different. 15 divided by the sine of 35. Yes. KJ is equal to 26.151152, depending on how you round that. We still need to find LJ yet. LJ is my adjacent side. So if we're wanting to find the adjacent side, and we have the opposite side, we're going to have to use tangent. Opposite, adjacent, has to be tangent. So tangent of 35 degrees is equal to the opposite side, which is 15, over the adjacent side, which is LJ. You can call it Y, that's perfectly fine. As long as you label it on the triangle that way, that is perfectly fine. Is that for, no, this is all for part A. Solving that triangle, you have to find 3 things. To solve the triangle, it means you find all the missing sides and all the missing angles. Thank you, dear. So we're going to multiply both sides by the denominator, which is our unknown LJ, or you can call it Y. So then I have LJ times the tangent of 35 degrees equals 15. We divide both sides by the tangent of 35 degrees. And then you can pop it into your calculator. 15 divided by the tangent of 35 degrees. Yes, 21.422. Part B on this is actually a whole lot easier. Look at the angle that they give us. 45. And I have a 90, which means this has to be what kind of a triangle? It's a 45, 45, 90 triangle, which means I've got shortcut rules. Well, remember, 45, 45, 90s are isosceles right triangles. These two sides are the same size. How big is angle X? Oh, no. Angle X is 45 degrees. That's absolutely correct. You're welcome. Measurement of angle X has to be 45 degrees. And the length of XY we already know also. That has to be 82 because it is congruent to YW. So we got 2 of them out of the way. We just need to find our hypotenuse now, XW. Yes. This is an isosceles right triangle. It's a 45, 45, 90. When we have 2 angles that are the same, that means 2 sides are the same. And it's never going to be the hypotenuse because the hypotenuse is always standalone the biggest. All right, we don't know our hypotenuse. That's XW. But we do know the length of both of those legs is 82 times the square root of 2. So XW is equal to 82 radical 2. You can do it the way we did part A. You can absolutely go through and do this with sine, cosine, tangent stuff. It's a lot faster if you remember your right triangle rules. This one's not long leg, it's hypotenuse. XW is hypotenuse because it's opposite that right angle. With a 45, 45, 90, we don't have a long leg because the legs are the same size. So we have leg and hypotenuse. On a 30, 60, 90, we have long leg, short leg, and hypotenuse. They're all 3 different sizes. Tomorrow. Test is tomorrow. Alrighty. There's 2 more parts to this question. You guys okay if we go on to C and D? All right, let's go look at C and D. For C, how many angles did they give me? Really? They didn't give me any angles? I got the 90-degree angle, so I know it's a right triangle, but I don't know how big P is or how big N is. We've got two of the sides. How do you find the third side when they give you two sides? Pythagorean theorem. A squared plus B squared equals C squared. C has to be the hypotenuse, so 29 has to go in for C. A or B could be the 15. I'm going to put it in for B.
Square? Yeah.
Yep. And we don't know how big PQ is. Yep, so I'm going to call that X. 15 squared is 225, but how much is 29 squared? 841. So now we need to subtract 225 from both sides. So I get x squared is equal to 616. Then we square root both sides. Squared and square root cancel each other out. We got to simplify this. What goes into 616? 2. 2 times what would give me 616? 2 times 3 gives me 616. $308. What'll go into 308? So I have 2 times 2 times, that would be 154. Does anybody know what goes into 154? 2 again. So 2 times 2 times 2 times 77. 2 times 77 is 154. What goes into 77? 7 times what? 7 times 11. Okay, so I have 2 times 2 times 2 times 7 times 11. What can go into 11? What can go into 7? Nothing. I can only take out pairs. Here I have 2 2's, so that would be 2 squared underneath my radical. 2, 7, and 11. The other 2, the 7, and the 11, those don't have pairs. So they have to stay underneath the radical together. So with my 2 squared, the squared and the square root cancel each other out. So I have 2 times, and then I times these 3 together. What is 2 times 7 times 11? 154. So x is equal to 2 square root of 154, or in its decimal form, that would be 24.819. That just found our missing side, PQ. We still need to find our 2 angles. So if I'm standing over here at angle P, this 15 is opposite or adjacent? Opposite from angle P. Opposite and hypotenuse means I would have to use what to find this? Opposite and hypotenuse. Yep, that's going to be sine. So sine of angle P is equal to opposite, which is 15, over hypotenuse, which is 29. Because I said so. We have to find both P and N, so I had to pick one to start with. Yes, it is. What do you have to use to get P apart from the sine? Inverse. Yep, we use the inverse. So P is equal to inverse sine 15 over 29. And then when you put that into your calculator, the measure of angle P, 31.147 when you take it out to 3 decimal places. We also need to find angle N. So if I'm standing right here at angle N, then is 15 still my opposite side? Now it is the adjacent side. Adjacent in hypotenuse means I'd need to use what? C, cosine. Cosine of angle N is equal to adjacent, 15, over hypotenuse, 29. So just like we did with the other one, to get the N apart from the cosine, we have to use inverse cosine. So N is inverse cosine of 15 over 29. I was asked to do 4 of the most complicated problems on here because they're all number 20. But it gives you a chance to practice almost all of the different skills that we've done in this chapter. So then we pop this into our calculator. Measure of angle N is 58.853 degrees. Do you guys want to see a shortcut for the last one?
Yeah.
How many degrees does the triangle have to add up to? 180. And I know this is a right triangle, right? So the other 2 angles would have to add up to what? If I've already got 90 tied up in my right angle, the other 2 have to add up to 90. Well, if I find this one using sine, cosine, tangent, I can do 90 minus 31.174 and get this right here. So to find the second one, if I'm asked to find both angles, I could always do 90 minus what I found to find that other piece. All right, one last part.
So they have like a steak. You know, like how oddly shaped the steaks are. Yeah.
All right. How do I find angle R? Add 19 and 90 and then do what? Close, not divide. Subtract it. There we go. Measurement of angle R plus 90 plus 19 equals 180. So when I add the 90 and 19 together, I get 109. When I do 180 minus 109, I get 71. And then I need to find my other 2 sides by standing up here at the 19-degree angle that they gave me. We're going to need to find the hypotenuse. We're going to need to find the opposite side. We know the adjacent side. The adjacent side is 43. Do you guys want to find opposite or hypotenuse first? Opposite, sounds good. Opposite and adjacent means I need to use what? Tan. So tangent of 19 degrees is equal to my opposite side, which is UR, over my adjacent side, which is 43. Multiply both sides by 43, and I'll have my opposite side. Because that gets my adjacent side UR all by itself. I got 14.806. So there's the opposite side.
Equals your.
Your.
You're so corny, bro.
There's nothing wrong with that.
She's just lame. I have no sense of humor.
We have the adjacent side, and we need to find the hypotenuse. Hypotenuse and adjacent would mean which one? Cosine, yes. Yes, dear. 43 times tangent of 19.
Oh, because I did too.
Yep, that'll make a difference. All right, so this would be cosine of 19 degrees.
Stop.
Is equal to adjacent, which is 43, over the hypotenuse, which is RT. We have to multiply by the thing that we don't know, which is side RT. That's my denominator. That's why we're multiplying by RT, because it's on the bottom. So I have RT times the cosine of 19 degrees equals 43. And then we have to divide both sides by the cosine of 19 degrees. Squeeze it in there. RT is equal to 45.477478, depending on how you round. We got 4 minutes. If somebody has another quick question, I'm happy to go over it. You guys have the D-lunch time to work through it. I'm happy to answer questions. Like I said, I'm posting videos of all of my classes today, so if you had a question about one that I haven't gone over yet, you might want to check out the videos. They're already posted. Fourth period's video should be going up shortly. Does anybody have one last one that they want to talk about? I am staying after today. I have office hours from 2:30 to 3:30, so if you want to stay after school and study with me, you absolutely may do so.
Office hours on Mondays?
Mondays and Wednesdays.
Oh,